Let's go back to our mole map and do a problem relating the number of grams of a compound to the number of molecules in that compound. So if you remember from our previous talks here that our mole map will kind of show us how to go from grams of anything to either molecules, but we always have to transition to moles in between. And so far our question is how many H2O molecules are in 5 grams of water. Well, we're starting with grams of water and we're going to want to go to moles of water, so we need to know how much a mole of water weighs. So to do that, we need to find out the molar mass of water. So if we have our H2O molecule, that means we have 2 hydrogens, and from our periodic table we know that its atomic weight is 1 gram per mole, right? And then we have 1 oxygen, so we have 1 times its atomic weight from the periodic table, which is about 16 grams per mole. So if we add those up, we get 2.02 grams per mole and 16.00 grams per mole. And so we're ended up with 18.02 grams per mole for water. So 1 mole of water molecules weighs 18.02 grams. So we're going to have to, clear that out here so we have room to do our problem, but we'll just write it up here for a reminder: 18.02 grams per mole. All right. And so to do this problem, we should kind of look at where we're going here, right? And we're going to go from grams of water, and then we're way over here, so we're going to have to go to moles of water next. And once we're at moles of water, we can go to molecules of water. And remember, each one of these arrows means we need a conversion factor to go from one box to the next. So we're going to start out with our given, which is 5.00 grams of water. And the next place we're going to head is moles of water. So we need to know how much 1 mole of water weighs. And that's the calculation we did earlier, that we know that 1 mole of water weighs 18.02 grams. Right, and now the next place we want to go is molecules of water. So we need to know the relationship, how many molecules of water are in 1 mole of water, and that's just going to be Avogadro's number. So there are 6.022 times 10 to the 23 molecules of water in 1 mole of water, right? And so to make sure we have it set up correct, our grams of water are going to cancel out, our moles of water are going to cancel, and the only units that we have left are molecules of water. So if you take 5 times 6.022 times 10 to the 23rd and divide it by 18.02, then you should end up with 1.67 times 10 to the 23rd molecules of water. Right, and if you remember way back when from our density lectures, we said that the density of water is 1 gram per milliliter. So if you had 5 milliliters of water, you'd have that many water molecules in there. So that's a very large number, right? So it gives you an idea of the magnitude of the numbers we're talking about.